Okay, ladies, so you're going to do the corrections first, and then move on to that last one that you have there. How far are you in school now?
We are busy with integers.
Integers. So what does it look like? You see?
But so she does a different method.
Yeah, it's basically the same, just looks different to you. Okay, so you're doing that now. And then you're going to do this. Okay, we're doing this as well. Did you have, you've done this already? Where is that? Oh, is that from the textbook? Okay, never mind. Good. I have a few from the same textbook, so we'll just have a look at that. Okay, I've done the ones on the board that one or both of you have wrong. We have to remember last week I wrote on this board factorize, factorize, factorize. That's always what we have to do. If we have more than one term, we need to factorize. And in this case, we removed a b on top as a common factor, and as you can see, there's a b and a b that can cancel out. So we left with a plus 1. 13.4, the same applies here. I can remove a as a common factor on top. And then at the bottom, it's already one term, so there's nothing I can do, but I can cancel that a with this a. That leaves me with a plus 2 over 5. So if you had it wrong, just make corrections. So what is the key here? Factorize, factorize, and factorize. Done?
Yes, sir.
Cool. 13.5. I don't know what you've tried here. You even tried to cancel out these two. We can't. We have more than one term. So more than one term means factorizing. That is a trinomial. So looking at the factors of that trinomial, we'll have 1 and 2. And on this side, 1 and 6, 2 and 3. We need to get 1 after we subtract. So if I multiply 2 to 2 and 1 to 3, 2 to 2 will give us 4, and 1 to 3 will give us 3, and the difference there will give us 1. So that means that I have 2x and 1x. The 2 is multiplied to the 2, so they are in different brackets, and the same applies to the 3. The biggest product must be positive, so 2 times 2 is 4, and that is minus 1. At the bottom, we just have a common factor. And you can see I'm cancelling this out by using a different color or pencil if you have a pencil. So to make sure that you don't, it doesn't seem that you're scratching out something. You factorized it and then you've done that. And then the last step is just to write down what is left. So you can see if your factorizing is not done correctly, you will not be able to remove a common factor. .1. Okay, so again the same. I check on top. We have 3 as a common factor. There's my 3 out. At the bottom, 2 as a common factor. On top here, 6 as a common factor, and below here, a difference of 2 squares. So this first step is already worth 4 marks. You get a mark there, a mark there. Let me just use a red pen to indicate you'll get a mark for that, a mark for that, a mark for that, and a mark for that. That's already 4 marks, and something like this will count like 6 marks. You already have the majority of the marks, but you have to make sure that you do the factorizing correctly. So before I cancel out anything, I realize that there is something more that I can factorize here. There's a difference of 2 squares again, which becomes x minus 3 and x plus 3. And then I cancel out. This x squared plus 9 cancels out the x squared plus 9. The x minus 3, the x minus 3, this 2 divides into the 6 3 times. So on top we are left with a 3. Let me just use some highlight here. We are left with a 3 and a 3. So 3 times 3 is 9. At the bottom we have this bracket and then the same bracket, so that is x plus 3 squared. Good? All done? Done? Okay. Yeah, you just say no, I'm not done. Hold your horses.
Okay, I'm done.
Cool. Then this one, 13.1. Removing 3 as a common factor. Let me just see. Why is that one here? Let me see what I've done here. Oh. It seems to me that one is. I don't know why this one is here. It's not supposed to be here. It's supposed to be there in the beginning. Okay, 13.1. There is 13.1, or whatever that is worth. So on top there is a common factor of 3. At the bottom there is only a 3, so no common factor, but they will cancel out. That leaves with x minus 2. Okay, then 14.2. Must say with this one you've done better than with the previous one. So 2 things that you have to notice. The first is that I'm going to change the divisions into multiplications. Now that is important, but then we swap the fraction right behind the division and then factorizing again. So factorizing and changing division into multiplication. So looking on top here in our first fraction, 2x is a common factor. I remove the common factor of 2x, I'm left with x minus 3. At the bottom, a difference of 2 squares. Then I swap these 2 around, so the one that was at the bottom is now on top. There's x as a common factor. The part that was on top is now at the bottom. There's nothing I can factorize that with. And then looking at the last term here, the division again became the multiplication. Numerator and denominator swaps places. There's 3 as a common factor, so I remove that. So the first step here will give you 1, 2, 3, 4, 5, 5 marks just for the first step. And then you have to check what is left. On top we are left with a 2 times a 3, that's how I got a 6, and x times x, that's how I got x squared. At the bottom we are left with 1, so we can just leave that out. We don't have to write that as 6x squared over 1. Happy with that? 14.3, very similar to the previous one. I factorize the trinomial into 2 brackets. At the bottom I remove 3x as a common factor. Here's a division, so only this fraction swaps around. This one stays the same, there's no division in front of that. At the bottom there was a x squared minus 16, which is a difference of 2 squares. On top we have a common factor. So girls, if you can't do the factorization, or if the factorization is done incorrectly, then you're most probably going to lose all the marks here. Then check to cancel out. Here's an x minus 4, that cancels out with an x minus 4, an x minus 2 with an x minus 2, x plus 4 with an x plus 4. So on top we have a 1 left. Now we need to have the 1 there because it's a placeholder. At the bottom we have 3x times x squared, 3x cubed. So some of the examples that I have on the board is from you use class in maths in school, that big blue book with the checkered lot. But they're all books. No, it's that one. So a lot of the examples I have here is from that book. So hopefully by seeing it a few times it will help you. We're not going to use the book, I'm just wondering which book you're using. Both finished?
Yes, sir.
Okay, the same with this one. I changed the division into multiplication. Then factorized this one by removing 6 as a common factor. Can't do anything with the bottom. That part that was on top now is at the bottom, and the part that was at the bottom is now on top. Remove the common factor in each of them as well. Then I realized that here's another difference of two squares, so I factorize that into this. So once everything is factorized, I cancel out as far as I can. So now you can see that the 6 here cancels with the 6. The two a squares cancel each other. A plus 1 cancels out with this one. So on top we are left with the a minus 1 times the a minus 1. That's why it's a minus 1 squared over a squared. And you leave your answer like that. Happy with that one?
Yes.
So it's not as if you had everything wrong, but you've made mistakes here and there. So you will still get marks even if I do it on the board. It doesn't mean that you're not going to get any marks for something like this. Okay, now we get to this. Now some of this should be familiar to you because we have done it last year. I'm going to do a few examples and then we're going to do quite a few together. Okay, you can copy that, example 1. So if we add fractions, what needs to be the same?
The denominator.
The denominator. So between the numbers 2, 3, and 4, what will be the smallest possible denominator?
2.
No. I have to multiply each of them by something, and that something should give me the same answer. So if I multiply this one by 2, I'll get 4. If I multiply this one by 2, I'll get 6. 2 and 6 are not the same, so I can't use that.
So can't be
12 will work. 24 will also work, but we have to go as small as possible. So we have to find a common denominator, and in this case, the lowest common denominator is 12. So that means that we can change each one at the bottom to 12 by multiplying it by a certain number. Not the same number, but a certain number. So that means that the 12 goes at the bottom. So how did I change How did I change 2 into 12? What did I do to 2 to become 12?
2 times 6.
So we multiplied by 6. So there was a 1 on top, so that's 6 times 1, which is 6. How did I change 3 to become 12?
3 times 3 times
4. And the 4?
4 times 3.
3. That's right. Okay, this is wrong here. Sorry, my mistake. It should look like that. Now check this. Quickly check this. Check. What is 6 over 12 if you simplify it?
2.
No, not 2. What is 6 over 12?
Half.
Can you see it's still a half? There's the half. So what is 4 over 12?
1 over 3.
1 over 3. And what is minus 3 over 12?
1 over 4.
Minus 1 over 4. So we haven't changed the value, we've only changed the format. Now all that is left to do here is to add like terms. So 6 plus 4 is 10, minus 3 will give us 7, so this answer is 7 over 12. Of course your calculator can do this. I'm not trying to show you how your calculator cannot, but your calculator can't do it. But if we get to a stage like this where we have x's, then the calculator is of little use. But you could use the calculator to do that calculation. This one. So if I go with, and I go with a fraction here, and I fill in 1 over 2 plus 1 over 3 minus 1 over 4. You see, it's the same answer, and it should be the same answer because we've done everything correct. So what did the calculator do? The calculator changes it into the same denominator and then add it exactly like we've done it here. Okay, now let's get to this example. So that first one was more grade 8 and grade 9. This one is borderline grade 9 but really grade 10. Okay, the first thing to look at are the numbers. What is in the front here that we don't see?
1.
A 1. So between the numbers 1, 3, and 4, what will be the lowest common denominator?
1.
No. Same as what we've done here. How did I get the lowest common denominator there of 12? We worked out which number is the number that all of these 3 can divide into, so that we can get a number to change them all to become 12. So what will be the number here between 1, 3, and 4? What is the smallest number that 3 can divide into without leaving a remainder? And 4. Check. What is the smallest number that can divide in that 3 and 4 can both divide into? That means, what is the smallest multiple of 3 and 4? What is the smallest multiple? The lowest common multiple.
4.
No, it can't be 4. I have to multiply 3 with something and 4 with something to make them the same. What is that number that's the same? Come on.
So can't you say 3 times 4 times?
Okay, so what is the number I'm looking for?
12.
12 again. 12 is the smallest number that 1 can divide in, 3 can divide in, and 4 can divide in. So we're going to use 12. So we treat the numbers like we have done before. Okay, now here's the other thing that you have to keep in mind. Now check, we have unknowns, x, x squared, and x. Your lowest common denominator, your lowest common multiple, is the one with the highest power. So that means x squared goes here. I'm just going to repeat what I said just now. So we look at the numbers. The number 1, 3, and 4. The smallest number that all of them can divide to without giving us a remainder is 12. Then if an unknown is repeated like this, we have to use the one with the highest power. So if it feels wrong, it's right. Okay, now let's start here. What did I multiply 1 with to become 12?
12.
12. What did I multiply x with to become x squared?
X.
X. Can you see there is the 3 still that was on top? And now we're with minus. 3 times what will give me 12? 3 times 4. X squared is already x squared, so there's no more x's to be multiplied, so it stays like that. And the one on the side there? 3. So this will be 3. X. Why is there another x there all of a sudden now? Is that one of your boyfriends? Better not. I will pull the chain across this. Why is there an x here?
Because of the 4x.
We shorted x squared now.
Yes.
Okay, now we are done. The 12x squared stays 12x squared. We're not doing anything with that. And usually we don't do anything with it, it stays like that. 12x times 3 is 36x. minus 4 plus 6x. Are there any like terms here?
Yes, sir.
Which are like terms?
The 36x and the 6x.
Good, so what is 36x plus 6x?
42, sir.
42, cool. We are not done yet. There's something else we can do.
42 minus 4.
No, we can't do that, they're not like terms. Can we remove a common factor on top? What is the smallest number that divides, or the biggest number that divides into 42 and into 4?
4.
Check. What is 42 divided by 4? It's 2 only. Okay, so we remove 2 as a common factor. That leaves me with that. And there's one more thing that we can do, since the top part is factorized now, and it's only one term. This 2 divides into itself once, and into that one 6 times. So we are left with 21x minus 2 over 6x squared. Quite a bit now.
Yes, sir.
Way more difficult than the other one. So who made you the smoothies?
My mother, sir.
She's nice. So it's a nice smoothies.
Yes, sir.
What's in it?
Yogurt and kale and frozen fruit.
Kale. Is Kale not spoiling the whole thing there?
Not actually, sir.
I know it's very healthy. That I have. Okay, let's have a look at this one. Two over x minus 1 minus 3 over x plus 2. That's just my example. I was looking at the one. We don't need this one where we have, because there's no factorization required here. Let's just move that out of the way. We can move this one, yeah. Now this is where you get confused. Listen closely to what I'm going to say. This is x minus 1 and that is x plus 2. They are completely different. Although the x's are the same, the fact that I have 2 terms means I have to use everything there. So my new denominator, and this is a difficult one to wrap your head around, the new denominator is this one as well as that one. So I have to use x minus 1, I have to use x plus 2. The fact that they both have x's in them doesn't make a difference. Okay, now here's the next step. Here's the next step. How did I change x minus 1 to become x minus 1 times x plus 2? What extra was put here at the bottom? From x minus 1 to x minus 1 times x plus 2. What is extra? How did I change that to that? What did I multiply this with to get all of this? Check. Here's x minus 1. Here's x minus 1. And now all of a sudden I have that bracket extra. So this bracket is extra here. And this would be 2 x plus 2. Check again. X minus 1 is multiplied by x plus 2. That means the denominator must be the numerator must also be multiplied by x plus 2. Let's look at the second one. What was extra to this one now? The x minus 1. So the minus 3 is still in front, and here is the x minus 1. I'm going to go back to the previous one just to make sure that you understand what I'm saying. If I go back to this one, in order to change this into that, I need to multiply by 12 and by x. So in order to change x minus 1 to x minus 1 times x plus 2, I have to multiply with an additional x plus 2 on top. And the same applies with this one. This was x plus 2, it's now x minus 1, x plus 2, so that means that x minus 1 is short. You can just ask yourself what is short, and then you do that. What do we do next? Now we need to multiply out the brackets. Now. So we're doing this now. Each one is each number in front of the bracket is multiplied into the bracket. Note that the denominator stayed the same. I did not change that. I'm not multiplying that out because it's already factorized. So multiplying on top here, 2x times 2 times x is 2x, 2 times 2 is 4. Then over to the next one, minus 3 times x is minus 3x, and minus 3 times minus 1 is plus 3. Now we have to check for like terms. What are like terms here on top? 2x and minus 3x. What is 2x minus 3x? Negative 1x, I agree with that. Or just negative x is also fine. And 4 plus 3?
So is it 4 minus 3?
No. There's a plus in front of you and there's a plus here.
Oh.
4 plus 3. That is 7. What happens to the denominator, the bottom part? It stays the same. It's already as far as we can go. Now check on top, is there a common factor that I can remove, like 2 or x or anything like that? There's no common factor. Clearly not. There's not a 2 that I can divide to anything. So then that is the final answer. Can I go to the next one?
Yes.
Okay, now this is getting tricky. See, we're going to need factorization again. How will we factorize this? A difference? 2 squares. So what will be my factorizing 2 brackets here?
X minus 2 and x plus 2.
Yes. That's always an easy one to see. And then over here, we need to get the factors of 4, and to add them give us minus 4, so the factors of 4 is 1 and 4, 2 and 2. Can only be 2 and 2. The plus in front of 4 says that we're adding. The negative there says they will both be the same, both negative. I'm going to rewrite the whole thing just like it's there. I'll just write that as a single bracket. I know I'm cheating here because so you can see that is the same, except I'm going to change this to become 1 bracket squared. Now you have to listen carefully to my reasoning here. You have to decide upon a lowest common denominator. So if I have to find a lowest common denominator, I have to use every bracket. Look at this one. I use this bracket, I love bracket, I use this one, and I use that one. So we have to use every one that is different. So that means we have to use x plus 2, and we have to use x minus 2. But note Now I have to go back to this one. The lowest common one is the one with the highest power. So there's an x and an x. There's a squared. So again, back to this one, that means that we have to use the bracket squared. That is crucially important, this too. I want to even put a highlighter there that you don't overlook this when you look at this again. Okay, now we have to go to the top part again, because we have to do whatever we've done at the bottom, we must do on top now. So there's the 2 that was there. Check, that 2 is this 2. So of this, what is extra now to get from there to there?
Is it x minus 2?
That is correct. We already have 1x minus 2. We already have x plus 2, but here we have 2 of them. So that means x minus 2 plus the 3. Now we're in that one. What are we short there to make up what we have here?
X plus 2.
That is correct. Well done. So you see, if you just follow a certain pattern here, you can't get this wrong. Well, you can get it wrong. But the chances of making a mistake is getting less and less. Now what do we need to do more? What do we need to do?
Find the common.
No, we have to get rid of the brackets now. So I have to multiply it in again, like with the previous example. I'm keeping the denominators the same. Two times x is 2x. 2 times minus 2 is minus 4. Now we're with the second term. 3 times x is 3x and 3 times 2 is 6. Now we need to look for like terms. Again, the denominator stays the same. I'm not changing anything there. It's already factorized. Two x plus 3x, 5x, minus 4 plus 6, plus 2. No factorizing, no common factor, so that is our final answer. They're getting more and more difficult. But since you had some kale for lunch, I'm sure it will help the brain cells. Okay, now we're getting to the examples I have on the paper. So you can check on that paper, you have to paper here.
Yes, sir.
Okay, we're going to do all those on the left-hand side of number 15. So the last page, number 15.1 is the first one. So I want you to do that one. I'll give you a few minutes for that, and then see if we can get to the same answer. Check your examples that we've done just now to make sure that you're on the right track. So what do we have to decide first? The new denominator. So looking between the numbers here, what is in front of the b?
1.
And there we have 2 and then we have 3. What is the smallest number that we can divide 2 in as well as 3?
And say 2 times 3 and 3 times 2.
So what does that give us?
6.
6. And b is in all of them, so this will just be 6b. You can see that is the crucial part. This is where you lose or win everything. Okay, so now we have 6b at the bottom. Now you have to find out what you have to do to the top to get them the same. Do you watch the video afterwards?
Yes, sir.
Don't lie to me.
I do, sir.
You rather do TikTok than watch my video.
No, sir.
Okay, so to change the b into 6b, what did I do to it? Multiply by what? To change the b into 6b,
Times 6.
times 6. So I have to multiply the top part by 6. How did I change 2b into 6b? Multiplied by 3. How did I change 3b into 6b?
Times
Times 2. Okay, now we just have to simplify by multiplying out. So this is 5a times 6 is 38. 3 times 3 is 9a plus 2a. And 30 minus 9 plus 2 will give us 30 minus 9 plus 2 will give us
23, sir.
so 23a over 6b. Are we getting there?
Yes, sir.
Slowly but surely.
Yes, sir.
Any questions here?
No, sir.
Okay, next example. And I think this is the one that you find in school as well. What is the new denominator? Are there any numbers in front of them that we have to consider?
1, sir.
So that's no. So we only have to look at the unknowns. So for the lowest one, do we pick the lowest power or the highest power? The highest power. So that makes this one x to the power of 3. Now you have to fill in the rest. So in order to change 1, check, to x to the power of 3, I have to multiply by x to the power of 3. What do we have to do with this one? Multiply by what?
1,
How many x's do I still short here?
2,
So that means 2x squared. How many do we short there?
1, sir.
Only one x, so this will be 3x. And the last one? No, it was x cubed. It's still x cubed.
Just x, sir.
No, no, not just x. Just,
4x.
no, just 4. There's already enough. I didn't change anything yet. This one stayed the same now.
Yes, sir.
And that's our final answer. There's nothing we can do with that. That's where it's going to stay. All happy?
Yes.
No like terms, so we stop there. Okay, now this one is very similar to the example that we have done previously. So first question that you have to ask yourself, what will be the new denominator?
X plus 5 and x minus 3.
We have to use both, yes. Now I have to work out what did I do to the first one, what did I do to the second one in order to get that.
Then I say 2x minus 3 and 3x plus 5.
Yes, so the x minus 3 goes in here, and the x plus 5 goes in there. So what do we have to do with the brackets on top?
We have to simplify.
Yes, multiply them out. Simplify is the right word. Multiply it out, simplify it. 2x minus 6 plus 3x plus 15. Then collect like terms.
2x and 3x.
Yes, that will give us what?
5x.
5x.
Plus 9.
Plus 9. That's correct. And that is done. No common factor, nothing that we can remove there. Okay, then the next one. I'm going to get you to do that one. So the first thing to get,
Denominator.
the denominator. What is the denominator?
X plus 3 and x minus 3.
Both of them, that is correct, I like that. So we have the x minus 3 on top here. We need to multiply it by something else. We have the x plus 3 on top there. We have to multiply it by something else. That something else is my question to you. first one.
Yes.
Check closely. Check, both of you. This was x plus 3. Here's the x plus 3. We showed that one. So that means x minus 3 must go there. Going to this side, it was, I'm not looking at the top, I'm looking at the bottom. This was x minus 3. So that means we short the x plus 3. Happy with that?
Yes, sir. Can you please explain it?
So here we have x plus 3. Let me use some highlighter to make it easier to understand. I'll use this as well. Here we have x plus 3. Here we have x plus 3. But now we don't have x plus 3 anymore. I multiplied it by x minus 3. So the x minus 3, this one was multiplied by, I have to multiply the top part by that one. If I look at this one here, here was an x minus 3 and there's an x minus 3. So for this one, the x minus 3 is already there, but we shorted x plus 3. This is the one in green here. Okay, and now we need to multiply out on top. Just note what I have done here. I realized that there's a negative here in front. So I kept this in a bracket after I've multiplied it out with a negative still in front. And that negative needs to be multiplied in to each term on the inside. We have x squared minus 6x plus 9 minus x squared minus 6x minus 9. We need to collect like terms. Here are the like terms. Those two are like. Those two are like, and the last two are like. So let's look at the yellow, the x squared.
So doesn't it cancel?
It does, indeed it does. And if we look at the green,
What do you mean negative 12?
it gives us negative 12, that is correct.
And then 9 cancels out.
So that is only negative 12x left on top. And we still have a x plus 3, x minus 3. Okay, this one is for you. I'm going to rush this one a bit because we're almost out of time. So that can be factorized like that.
then we have to write that bracket afterwards.
You don't have to write it out because we're not going to multiply it out. We are going to use the square though. Okay, so what is the new denominator? The two brackets now, x minus 1 and x minus 2. So x minus 2 and x minus 2 and x plus 2. But you can see there's a square, so that means that this one, you must use the square. The highest power is the lowest one. So in the first one, what is short here?
X plus 2.
You said that at the same time, but it's not true. Here's x plus 2, there's x plus 2, that's fine. Here's x minus 2, here's x minus 2 squared. So we short x minus 2. And on that side, what do we short there? Check. Here's x minus 2 squared. Check the board. Here's x minus 2 squared. So clearly this one,
Yes, sir.
x plus 2. Okay, once we have that, we just need to simplify what we had on top. So this is 3x minus 6 plus 2x plus 4. And that will give us the same denominator once again. And the denominator x minus 2 squared. X plus 2 on top, 3x plus 2x is 5x minus 6 plus 4 is minus 2. And that's our final answer.